Hello and welcome to this special edition of FreeCodeSession. In this video, I'm going to talk about test doubles and mocks, what they are, and what my preference is, which is a little different than the way I think things have moved in recent history within the .NET community. Just to state for the record, I am the author of a mocking framework called Rocks. I've used lots of mocking frameworks within my career, and I do have a bias towards using them. I'll try to be objective in this video, but I wanted to state that up front. When we talk about mocking and test doubles and stubs and all these things, I've always liked the way that NSubstitute defines it. There's lots of definitions you can find out there, and I encourage you to look them up, but I like the approach that NSubstitute takes, which is just substitute for the type you need. And that's actually what drew me towards using NSubstitute early on in my career when mocking frameworks started to become a thing. It cut through, I think, a lot of the confusion and just said, make it simple and do it this way. If you want to look for specific definitions, go ahead. But that's kind of how I take this whole thing, which is you're just creating something that's taking the place of a dependency that you don't own, that's hard to manage, potentially, especially in a unit test. So the example I always have that comes to mind is if you're building a system that needs to validate a credit card, you probably need to call some kind of service that may be hosted by a third-party SaaS solution. So trying to call that in a unit test may or may not be the thing you want to do. It all depends on what environments they have available and how fast you want your test to run. Typically, you're testing the code that you wrote, not the code that you're dependent on. So if you can isolate your code such that your code doesn't depend upon that to actually run, you're probably in a better situation even beyond just a testing perspective. I will say that using mocking frameworks like Rocks, NSubstitute, MOQ, and others can be overused, just like anything that we do when we write software. It's a valuable tool. I think that they help when you are writing tests and keeping things separated and easy to create and maintain. But they also have a danger of being used everywhere, especially if you see an interface, you're supposed to mock it. And that can actually be detrimental. A couple of examples that come to mind is what if you want to test your registrations for your IOC? I've seen people that go and use iService collection and create mocks for that. And I'm thinking, why do that? You have a service collection type. You might as well just use that in your test and then verify, is that service collection set up correctly at the end of your test? Another one, which might be a little bit hard to believe, but I've seen people that will try to mock out interfaces like IEnumerable because they have link in play and they think that that needed to be mocked out. And I said, use a list. That's a simple approach. You know, that makes things so much simpler. There are a lot of cases too where just using a concrete type that is in all likelihood probably going to be the thing that you're going to use when you run your code is a perfectly valid solution to use when you're writing your tests. So use that. So yes, mocking frameworks can be overused. I completely agree with that. This is the article that motivated me to do this video. And this is something that's been a topic that I've mulled over for the past couple of years. And I've heard people start to put down, as I said before, mocking frameworks. And I kind of wanted to always address it. And this article just is the one that was the catalyst and moved me to do this. I actually don't prefer using test doubles over mocking frameworks. Moreover, I don't find mocking frameworks to be as bad or horrific or complicated or confusing as is made out not only in this article, but in others that I've seen as well. So a couple things that I want to address. I'm not going to go through everything in this article, but there are a couple things I want to point out in specific. The author mentions that test doubles focus on behavior, not implementation, and then comes up with a couple of examples, writing tests to show how this is the case. I look at this as being you are writing the code that you're testing. You're not writing the code that is a dependency that is going to be potentially resolved at runtime when your code executes or something like that. You know the behavior, you know the implementation. Arguably, you don't know the behavior of the thing that you're calling, how that all works. You don't know what that's actually doing. But what you do know is the code under test behaves in a certain way because of how it's implemented. And so from that perspective, I found it interesting that even though this section talks about how a test double focuses on behavior, you still have to create an implementation of all the interface's members. Moreover, the author creates a did store helper method that you use in tests. So that this focuses on behavior rather than implementation, I find a little odd. Because again, you have to know how this interface is defined and you have to create an implementation of that interface. The author also states in this section about having to understand the mocking framework syntax to read and modify the test. I don't see that as necessarily being a negative. If you're going to use any framework, you're going to have to understand how that framework's API is defined and how you use it. This is no different. And in this case, I have to know that there is a helper method called didStore so that I can verify, did I onboard a new product correctly or not? Syntax is helpful. When I first started using mocking frameworks, I looked at RhinoMocks and I did not like it. I felt it was harsh. I felt it was very confusing to use, and that actually turned me off from mocking frameworks for a little while. And Substitute was the one that made it simple to understand. But again, when you're using anything else, you have to understand its API, its syntax, whatever it's doing. And so that all depends upon how that's written. And a good API is typically easy to understand because it's consistent and the names of things match to what you're trying to do. So I personally don't find this to be a detriment with mocking frameworks. The author leads into the section on readability and maintainability by saying that the testable version is more readable. That's personal preference, and I also have a personal preference that I don't find it unreadable, but I don't see how the code that was written for the test, if I move back up here, let's go to the one that was written here, you can see that you have a repository that's a substitute for this interface. There's an error here. You should pass in repo to product service. You onboard new product, and you see that you received a call to store where the product has an ID of this. I find that perfectly readable. I don't see how that's an issue. The author states that test doubles are cleaner and more understandable because the logic is in a separate class, not intertwined with the test setup code. It's not bad if you have that code within a test double, but personally, when I write tests, I make those methods static. And I also try to run my tests with parallelism in play. And I do that not only for performance reasons, but sometimes they've uncovered odd cases where I have a race condition between shared state that I didn't realize, and sometimes tests will start to fail randomly. That's actually good because that shows that my tests are not isolated, and I needed to do something to change my implementation so that I don't run into these shared state cases. I like when my test code has what it needs within the test itself. That's a general rule of thumb. That doesn't mean I don't put things in shared methods or shared helpers or things like that. But I generally try to put those things in the same place because I find that to be more readable and more maintainable. One of the dangers of a test double that I found when I've tried to use them is they can end up having so much implementation in them because they're trying to cover all different cases that end up in a typical project. And so now you have the burden of trying to maintain this test double over time, whereas if I have all of my setup within each test method, I may need to change some of those to reflect changed things that I've done in my code, but at least I have them all there in one spot. I don't find that to be, though, that test doubles make things cleaner. That's a subjective statement. And I have always found that, again, having my stuff within a test helps to make it clear as to what that code is doing in that test. The example also in this article shows that if you wanted to support a test where a method throws an exception, now you have to go back into the test double and change it there. Whereas all I would need to do is write another test method and change the expectation for that mock in that place to throw an exception. This is a small point, but I think it's fair to bring this up in that if you're writing a test double, they can preserve the state across multiple method calls, and that can be challenging for mocking frameworks. I agree with that. It can be difficult if you have a test that needs to have multiple members invoked, and based on what they do and when they're called, you have to create some states so that that influences what the next call will do. And in a test double, that might be simpler to do it in one instance of an object. That said, if you're trying to preserve all this state, that may be a sign that your test itself is too complicated. Not always, but that can be a flag, and that may be something you want to take a look at and go, why do we have to have all of this state set up for just this one test? Performance. This is a big one because the author says that test doubles can be more performant than mocking frameworks. And fair enough to the author, it says can, because sometimes it all depends. I do think, though, that the author is making a good point that traditional mocking frameworks in .NET use techniques where they create types at runtime using some direct or indirect type creation with IL. And that can be a potential performance cost. One thing about rocks, though, is that this is all based on incremental generators. So the cost to actually create the type is minimal, and then how it performs at runtime is surprisingly well. So I created a repository that basically has different approaches for test doubles and mocks based on the code I found in the article. And I created also some tests that use rocks. So in this case, I create my expectations object. I set up an expectation on store. By the way, I wouldn't fully qualify it here with the type name, but in substitute also has an arg type. So in this example, I had to have rocks dot there to make it clear as to which one I was using. I then pass in that mock into product service, make my call, and verify. And then I did things with substitute and also a test double. And then I created a project here for performance where I basically just set up some benchmarks that turn around and call each of these methods. And what do the results show? As you can see here, using rocks compared to a test double, the test double is faster, but not by much. It also consumes less memory, but not by much either. In fact, this should be fluent assertions, but that's what I'm doing here by saying I'm using a fluent interface. Adding that onto a test double makes it a little bit slower and consume a little bit more memory. But again, we're not talking a lot here. With the rocks test, I'm using NUnit's constraint syntax, which is a form of a fluent interface. And I actually like using that. I like using NUnit from my testing framework, and I like using the constraint syntax to do my assertions. The point, though, is that in all three cases, the difference isn't that much. When you use something like nsubstitute, you'll notice that the time goes up by 3 orders of magnitude. You'll also notice that for the allocated memory, that's also 2 orders of magnitude more. Now, again, we're talking about 13 kilobytes here. We're not talking about gigabyte allocations. But when you start adding more and more tests to your test suite, this memory allocation, this performance of nsubstitute can add up over time. And one of the things that I've been very cognizant of with rocks is to try to make it as fast as I can. I have the benefit that all the mocking code is compiled into the test assembly, where I don't have to do any generation at runtime. But it's also the implementation of the things that are done in rocks that also, I think, have an added benefit. This is all the code that's created by rocks for the scenario when I want to create a mock for this interface. And so I can see it, I can look at it here, but it's all compiled in. I don't have to do any of that creation at runtime. This is also shown with benchmark mocknet, which is a repository that somebody created to compare all the mocking frameworks. I added in rocks at some point in its version history. And I've been surprised to see that Rocks is consistently the fastest and consumes the least amount of memory compared to the other frameworks. The stub is basically the base call where you don't have any frameworks in place and you're almost creating a test double, but it doesn't have any implementation. It's the smallest thing you could do. It's just, again, interesting to note though that Rocks is at the forefront compared to all of these other frameworks. Now, I'm not saying that other frameworks haven't done any performance testing or haven't done anything to make their code run faster. I do think, though, that Rocks has this advantage because of the way that the code is generated and compiled into the test assembly. So if you also have an aversion to mocking frameworks because of things you've seen with performance degradation, maybe take a look at Rocks and see if that actually helps address that concern. One last thing I want to bring up here is what the author states in More Focused Abstractions about the target types being small or big, and that if the target type ends up having a lot of members, a test double can be problematic. The author states, well, then that means you should probably make your abstraction or the target type that you want to mock smaller. And if you've authored it yourself, then you potentially can do that. But if you're referencing something, you don't have a choice. You have to take what's there. One of the frameworks out of many that I use in a code generation test project I have in Rocks references AngleSharp. And I noticed that one of the types in AngleSharp that you can mock ends up having a fair amount of members that you have to implement if you want to implement that interface. For example, ISVG SVG element derives from ISVG element. That in turn derives from iElement. And when you look at that interface, you can see there's a fair amount of base interfaces, and this one itself has a fair amount of members. If you want to create a test double for this, if you wanted to create something that you're testing that has AngleSharp in play, and you wanted to test really anything that derives from iElement, you have to implement all these things. And for writing that yourself as a manual test double, that burden can become quite high. And it's not just with AngleSharp. That's just one example. If you've seen some of the types in EF, they can be quite complicated as well. Coming back to the code that I generate in Rocks for the mock here, it does all that for you. So you don't have to write this all out as a test double to do an implementation for store or do an implementation for get. And that to me is also one of the advantages of using a mocking framework, is you can focus on just those members that you need for the test code in play. And all the other ones, you don't have to worry about. So in conclusion, I would say use what works. There are cases, as I mentioned at the beginning of this video, where I wouldn't use a mocking framework. I would use something else. I would take another approach that's arguably a test double. And that's perfectly fine. But I don't think there's something inherently wrong with using a mocking framework. In fact, I find them to be quite succinct and makes things easier to use to write tests where I have dependencies in play. And I don't want a quote-unquote real thing in play during my unit test. Now, if you like test doubles, that's great. If you feel like that makes you more productive and it makes things go faster for you, and any other kind of quality factor you can put in there to say, this is why I like it. If it works for you, great. But I also want to say that I think mocking frameworks are just fine. And I personally don't prefer them over test doubles. I tend to go the other way. And I'd be interested to hear what you think. So leave comments and questions below. Thank you for watching. See you in the next video.